Alright, in Algebra 1, we dealt with straight lines, linear things, and when we looked at the rate of change on a linear graph, we were always talking about what we called a slope. A slope is a constant rate of change. Okay. And if you remember correctly, our equation or formula to find slope was as such: y1 minus y2 over x1 minus x2. Now, your 1's and 2's may be the other direction. It doesn't matter. What matters here is that this x and y make one ordered pair, and this x and y make another ordered pair. That's all that matters. Now, in Algebra 2, we start dealing with lines that are nonlinear. So when we start looking at the rate of change, as you can see, that rate of change is not constant. So instead of calling it slope, we call it an average rate of change. Now, the formula for average rate of change looks like this: f of b minus f of a all over b minus a. Alright, now that looks really confusing, but we have learned everything we need to realize that that's not a confusing formula. Think function notation. Okay, we decided that f of x was the same thing as y. So this notation right here is the y value when x equals b. And this is the y value when x equals a. Alright, so this is a y, and this is a y, or a y1 and a y2. They're two different y values. Well, that looks very similar to what's going on over here, doesn't it? And then I just told you that we're focusing on the y value when x equals b and when x equals a. So this b and the a down here on the bottom are just x values, which is exactly what's going on there. So, what I want you to be very clear about is f of b minus f of a is the exact same process as y1 minus y2 over x1 minus x2. Okay, now we're not going to call it slope. We're going to call this average rate of change, even though sometimes it might be constant. But we're going to call it average rate of change because from here on out, when we see this, we're going to know the process is the same as if we're using that formula. It just looks more challenging. And that is average rate of change. So let's try an example. Okay, so here's an example. Find the average rate of change between the given points. Alright, so here is my x1, y1, x2, y2. That's a y. Sorry. Alright, so f of b is 9. F of a is 16 because they are the y values. Remember, f of is asking for y values. Over b, or the x value for 9, and 4, or the x value for 16, or that gives us 16. So we're going to work this out now, just like we would if it was the basic slope formula. 9 minus 16 is a negative 7. Negative 3 minus 4 is negative 7. Negative 7 divided by negative 7 is a positive 1. And yes, average rate of change really is that simple. If you can find slope of a straight line, you can find average rate of change on any given graph.